Hello students. So in this session I am going to start the basics of analytical instrumentation. Okay, analytical instrumentation. So what is an analytical instrumentation? What is an analytical instrumentation? So please write down a definition. Analytical instrumentation gives information about the composition of sample. Gives information about the composition of the sample. So what does it mean? It means that, for example, I'm going to take a sample like this, okay, and here this is a light source. Okay, this is a light source. So I'm setting some light, and this light falls on the sample, and some part of the light will be absorbed, and some part of the light will be transmitted. Okay, some part of the light will be transmitted. And now whatever the light was transmitted, this should be detected by a detector. Whatever it is detecting, it should display. This is known as analytical instrumentation. Okay, here the important thing is that we will be going through UR spectrometry, IR spectrometry, X-ray spectrometry. What does it mean? It completely depends on the type of sample we are going to use. For example, if I want to say, if I'm going to use an X-ray spectrometry, if I'm using the term X-ray spectrometry, it means that whatever is the light source, from there you will be getting the light as X-ray. And whenever the X-ray falls on the sample, some part of the X-ray will be absorbed and some part of the X-ray will be transmitted. And here the detector should detect the X-ray light, and that should be displayed. Okay, so then it is known as X-ray spectrometer. If from the light sample, if you are getting an ultraviolet rays, then you will be calling it as ultraviolet spectrometry. Okay, this is known as analytical instrumentation. Here the important topic in the analytical instrumentation is that how much light was absorbed and how much light was transmitted. How much light was absorbed and how much light was transmitted. Okay, so here the amount of absorption is directly proportional to number of molecules present in the sample. Okay, and amount or intensity of transmitted light is directly proportional to concentration of the material. Okay, that's it. So now what I am going to do is that I am going to take one more sample in this manner. Let P is the P naught is the incident light radiation and P is the now here we are going to see some of the formulae. The transmittance T is equal to P by P naught, and percentage of transmittance is equal to P by P naught into 100%. Okay, similarly absorbance capital A is equal to log base 10 1 by t, or else log t power minus 1, or else minus A is equal to log t, or else t equal to 10 power minus A. The relation between transmittance and absorbance is very important.